Hi, I'm Tom, amateur radio call sign N8FDY. Today, we're looking at another multimeter. This is the Greenlee DM-510A. It's wrapped a little different than most of the other meters we reviewed, but it still has some interesting properties. Let's open her up. Okay, you get the meter. It looks very similar to the one we reviewed last time. Then you get the manual, a little brochure. The manual's pretty good. And covers a lot. The only confusing part is it covers 3 different meters. So you have to make sure you're reading the part that applies to your meter. I got this for $150 at Amazon. This is the second of the 2 meters I believe are the sweet spot for the 6,000 count, and the ones that I recommend if you're trying to get the most economical meter that meets most of the criteria I set. It also comes with some nice silicon leads that are gold-plated. Take off the little safety cap there, and there they are. And comes with a thermocouple because it measures temperature, which I didn't test because I don't have an accurate way to test temperature. All right, we'll go through the features of this meter. The features of this meter include UL listed for USA and Canada, Cat 2 1000 volts, Cat 3 600 volts, and Cat 4 300 volts ratings. It's a 6,000 count meter. It has a basic DC accuracy of 0.2%, plus or minus 3 in the least significant digit. It has true RMS. It has a bar graph. It has auto check. It has low Z as part of the auto check. It has min-max, which they label as a REC button. It has a hold, has a relative or delta function. It has non-contact voltage detection. It has a thermocouple for temperature measurement. The fuses are accessible from the battery door. It has a limited lifetime warranty, and it comes with 2 AAA batteries. Okay, let's start out with voltages. You notice it has a yellow backlight, and the backlight only stays on for about 30 seconds. The trade-off between this and the EEV blog, the Bryman meter we looked at, is that meter stayed on for a pretty long time, the backlight, whereas this one turns off in 30 seconds. And that one came with a 1-year warranty that you had to send out, and it was UL listed for safety. And this one is UL listed for safety also, so that's what they have in common. The warranty for this is what Greenlee calls their limited lifetime warranty. And I'd say go to their website and read that, because it's interesting. Or you could download this manual electronically and read it. I'm no lawyer, but it sounds like they determine the lifetime on a case-by-case basis, because they don't actually state what the lifetime means in the terms of years, whereas Fluke's lifetime warranty they state as a minimum of 10 years. And it's their other explanation is it's also goes till 7 years after the meter was discontinued. So, but if you buy the meter and it's discontinued immediately, they will give you 10 years. But Greenlee doesn't explain any of that, of how long their warranty lasts. It just says they determine the lifetime. But it's still better than no warranty. All right, let's turn on the light. Let's go to DC and see what we get. 2.5005, and it shows up as 2.500. I can't argue with that at all. Here's 5.002. And mine says it should be 5.0009. And there goes the backlight again. This is a 6,000 count meter, so when we go to 7.5 volts, you'll notice that my alarm will go off. All right, we're back. Let's see. It's a 6,000 count meter, so if we go over 6,000 on the display, everything will move over. And there we go. 7.50, and this should be, it's measured as 7.5012. So that is correct. And there is 10 volts. 10.0015, according to my Keithley meter. This is the table of all the DC voltages I checked. All the readings met the manual specifications. The specifications for accuracy is average for this group of meters. Here's some AC voltage. I'm using my arbitrary waveform generator to generate a 60 Hertz AC voltage at 2 volts. Well, as close to 2 volts as that generator could make it. I'm using the Fluke 289 to make sure I'm as close to 2 volts as I can be, and it's 2.0006. And the meter reads 2.003. Oh, now it jumped up to 4. 2.004. Here's a table of the AC volts I checked, and all the measurements are within the accuracy specifications of the manual. The accuracy specifications are average for this group of meters. This meter is also manufactured by Bryman. Even though it has the Greenlee name on it, it comes from Bryman, and because of that, it has that mode memory where it remembers what you selected on each one of the rotary dial functions. So here, let's put on the backlight. You can see that we're in continuity mode, and if we turn it off and turn it back on, it'll still be in continuity mode. Now if I change it to capacitance mode, I can turn it off, and when I turn it back on, you'll see it's still in capacitance. So that's significant because I haven't seen any other meter do that. There may be others out there, I just haven't tested those. But this is the only one I tested, and I've tested a number of Brymans, and they all have the memory. These are kind of the lower end ones, the $150 ones, and I've also tested some higher end ones, and they all have the memory. Okay, let's do some resistance values. We're going to short the leads together to see what the lead resistance is. And suspiciously it says 0. This is a 1.004 resistor, and this shows it as 1.0. Pretty good, considering it's very hard for a meter to be accurate at the low end of a range. And this is a 600 ohm range, so 1 ohm is pretty much at the low end, so that's not bad. Here is 10.007, and it's reading it as, well, can't make up its mind between 10.0 and 10.1. But now it's, nope, see, so it's somewhere between there. Here is 100.069, and this comes out as 100.0. This is 1.0001 kiloohms, and it reads 1.001. Here's 10.02 kiloohms, and it reads 10.01. Let's jump up to the highest resistor this can read on my board here. This is the highest resistor I have on the board that this meter can read, and it's 9.97 megohms. And it reads at 9.97. This is a table of the resistance values I measured. All the values were within the manual specifications. The resistance specifications for accuracy is about average for this group of meters. Now we're going to measure some capacitors. The stray resistance of the leads is 0.02 nanofarads. So we're going to use the relative function to zero that out. Here is 10 picofarads, which is 0.01 nanofarads. And the meter reads 0.01. Here is 102.56 picofarads, which is about 0.1 nanofarad. And it reads 0.11 nanofarad. Here is 1.005 nanofarads. And it reads it as 1.04. Here is 9.921 nanofarads, and it reads it as 10.03 nanofarads. Here is 99.51 nanofarads, and it reads it as 99.8 nanofarads. Here's 1.009 microfarads, and the meter reads it as 1.011 microfarads. This is 10.294 microfarads, and the meter reads it as 10.95 microfarads. Here's 112.2 microfarads, and it reads it as 114.0 microfarads. Here is 944.5 microfarads, and the meter reads it as 1,026 microfarads. Oh, 1,024 microfarads. Oh, back to 6. Can't make up his mind. This is a table of all the capacitance readings I took. The highest value that I measured was 1,000 microfarads. It came out a little too high to meet the specification. The rest of the values met the specifications in the manual, and the accuracy specifications in the manual are about average for this group of meters. Because it uses nanofarads as the lowest range, the picofarad values, the uncertainty is too big to be useful. So I would not measure anything lower than 1 nanofarad with this meter. Here's the red LED, and it doesn't read a forward voltage, and it doesn't light it up. Yellow LED doesn't work either. Green LED doesn't work either. Here's the Schottky diode. Here's the small signal diode. Here's the rectifier diode. Let's do some continuity testing. Well, works pretty fast and it latches. So I have no complaints. Here's 0.89 microamps, and it shows up as 0.9 microamps. Here is 9.21 microamps, and it shows up on the meter as 9.2. Here's 99 microamps, and it shows up on the meter as 99.0 microamps. Here's 131.8 microamps, and it shows up on the meter as 131.9. Here's 1 milliamp, and it shows up as 1 milliamp. Here's 9.98 milliamps, and it shows up as 9.99. Here is 99.4 milliamps, and it shows up as 99.4. Here's a table of all the current measurements I made, and all the measurements were within specifications as stated in the manual. The milliamp and microamp ranges had above average accuracy specifications, and the amp range had below average specification for this group of meters. To replace the batteries, you need to remove the boot. Then there's one screw that holds the battery door, and that's a captive screw, so you won't lose it. And again, by some miracle, the fuses are accessible from the battery door. So that's pretty good. Let's look at the pros and cons of this meter. Well, the good parts, it's just under $150. It has third-party safety testing from UL. All but one of the measurements met accuracy specifications. The fuse is accessible from the battery door, and it has a limited lifetime warranty. Well, here's the not so good parts of this meter. The capacitance reading below 1 nanofarads aren't very useful. It was a little high on the 1000 microfarad reading. It was lower than average DC amp accuracy specifications and lower than average microvolt DC input impedance. Usually it should be at least 11 mega ohms, and this was much lower. And the backlight turns off after 30 seconds. This meter has some nice positives. UL listed for safety, has a limited lifetime warranty from Greenlee, average performance and a little above average in some cases. This is one of the 2 meters I recommend as the sweet spot if you're price sensitive. I definitely would say take a serious look between this and the EV Blog Bryman BR235. They are very similar. This has a bar graph, but it has a yellow backlight that turns off in 30 seconds. The other one has no bar graph, but the backlight is white and stays on a long time. So it's really between those two. For $150, I think you get a respectable meter that's safe to use if you want to play electrician. And of course, it's safe to use if you want to do lower voltage stuff or play with higher voltage boat anchor stuff. I think this meter, which is manufactured by Bryman but sold in the US by Greenlee, and is supported by Greenlee, is a good option. And I also think that the Bryman that is sold by EEV Blog is another good option. They're very similar meters. As usual, there is a written review with a link in the description below to my GitHub, which has all the written reviews of the meters. The rest of the 6,000 count meter reviews are going to be flukes. They, of course, cost more, so they end up at the end of the line because I started with the lowest price first. So if you don't want to spend any more then for this meter, this is a good thing to consider, or you can wait for the 10 to 20,000 count reviews, because there actually are some good meters that are priced a little less than this, which you'll see when we do those reviews. Anyway, I hope this helped. This is Tom, N8FDY, saying 73, and take it easy.